In this section, we will be working with function notation, this time given formulas. So looking at example 1, we have f of x equals x squared minus 2x plus 11. And remembering in function notation, here the f is the name of the function. This is the function f. X is the input variable. And that's something that you need to remember as we work through these. So in part A, we're asked to determine f of negative 3. Now the negative 3, because it is located inside the parentheses, we know that the negative 3 is the input value. So to determine f of negative 3, we're going to replace all of the x's with negative 3. So coming over here, f of negative 3 equals, looking at our function, here we have x squared, so I'm going to replace x with negative 3 squared minus 2, just copying that down. Now we come to another x, replace that with negative 3. Now as a general rule, particularly if the input is negative, you always want to include parentheses, just to make sure the negative signs stay where they need to be. And then don't forget the plus 11. Now, work it out. We have negative 3 squared is positive 9. Minus 2 times a negative 3 gives plus 6. And then plus 11. Adding from left to right, we have 9 plus 6 is 15, plus 11 gives us 26. So our answer, we have f of negative 3 equals 26. Writing this as an ordered pair, negative 3, 26. In part B, same idea. This time we're asked for f of 0. 0 is going to be the input, so we're going to replace all of the x's with 0. So we have f of 0 equals, replacing all of the x's with 0. There we have 0 squared minus 2 times 0 plus 11. Equals 0 squared is 0, minus 2 times 0 is 0, plus 11 gives us 11. So rewriting this in function notation, f of 0 equals 11. The ordered pair, the input is 0, the output is 11. Now it's worth noting here, this ordered pair is 0, 11, because that input value is 0. This is actually the vertical intercept of this function. Moving on to example 2, here we have another function. This one, h of x equals 2x minus 5. And part A, we're asked to determine h of 4. So the same thing we did in example 1. We're going to replace the x with 4. 4 is the input. So equals 2, replacing the x with 4, minus 5. Working it out, 2 times 4 is 8, minus 5. 8 minus 5 is 3. Writing it in function notation, h of 4 equals 3. That gives us the ordered pair, 4, 3. Now part B is a little bit different. I want you to pay attention here to the wording in part B. For what value of x is h of x equal to 17? This is very different from part A. Here the 17 is not the input value. It is the output value. So we can't just plug in 17 for x. 17 is not the input. We're actually looking for x. That is what we're trying to find here. So we have h of x is equal to 17. H of x, looking back up here, is equal to 2x minus 5. So we're going to replace h of x with 2x minus 5. So what we're looking for is what value of x will 2x minus 5 equal 17? That is the equation here that we are going to solve. So to solve it, same as we've done in the past, add 5 to both sides. We wind up with 2x minus 5 plus 5 is 0. equals 17 plus 5 is 22. Now we need to divide both sides by 2. 2x over 2 leaves us with x, so the x is isolated. 22 divided by 2 is 11. So x equals 11 when h of x is equal to 17. Writing this in function notation, h of the input is 11 equals the output is 17. And the ordered pair, 11, 17. In example 3, here we have the function g of x is equal to 71, and we're asked to determine g of 5 and g of negative 40. Now, the interesting thing that happens here, when you go to plug in 5, you write g of 5 is equal to, 5 is the input, so you're going to replace all of the x's in the equation with 5. The thing is, there are no x's here. G of 5 is equal to 71. And that's all you can do. So g of 5 equals 71. The ordered pair would be 5, 71. The same thing will occur when you have g of negative 40. So g of negative 40, go to plug in the negative 40. There are no x's on the right-hand side of that equal sign. So g of negative 40 is equal to 71. The ordered pair, negative 40, 71. This is what we call a constant function. It is constant because the output never changes. No matter what you plug in for x, no matter what the input is, the output will always be the same. In this case, 71.